All right, guys, today we're going to start Chapter 3, 3.1, Algebraic Expressions. I want you to pull out your red pen and fill in these notes for me. Okay, we're going to go through and talk about each of these different things. Chapter 3 in this section is very heavy on the vocab terms that you need to know. So these are going to be all terms that you're going to want to know for upcoming quizzes and tests, all right? Let's look at the first one, terms. Read to me what is a term, class?
Parts of the expression being added or subtracted together.
Very good. So you can see the different terms here. The first one is an x. What's the next one?
4x.
4x. What's the next one? 8. The next one?
Negative 10.
-10. Everybody, what's the next one?
3x.
3x. And the final one is?
x2.
X, not x2. We were going to say that. X squared. Everyone say x squared.
X squared.
All right. So those are what terms are. It's just the different parts that we add and subtract together. Let's look at the next one. Variable term. This is a term with a variable in it. Does anyone know what a variable is? I want everybody to underline that word variable. Does anyone have a guess? What do you think, Tacoby?
It's like a letter like X.
Very good. Everybody write this down with your pencil. A variable is a letter. Now, guys, what are the most common two letters used in math? What do you think? X and Y. We will see X and Y a lot, but a variable can be any letter of the alphabet, okay? So you can see here, these are my variable terms. X, 4x, 3x, x squared, 5x squared, and 7x squared. Those are just some examples of variable terms. The next one is a new word you maybe have never heard before. Repeat after me, coefficient. Guys, read to me what the coefficient definition says. The number part of the variable term. So this first one that you see here says 1x. What's the number in 1x, class? 1. So that would be the variable term. Let's look at this right here, 5x squared. What's the number in 5x squared? 5. So that would be the coefficient. Let's look at this one. What's the number in 4x? 4. So that would be your coefficient. Next up, we have something called a constant. Everyone say constant. A constant is the number that stands alone. So if I had 5x plus 2, what do you think the constant would be?
2.
The 2. It's a number that stands alone. It's not attached to a variable or it's not attached to a letter. Okay? Next up, we have something called like terms. Like terms are terms with the same variable that is raised to the same power. I'd like you to pull out your red pen, and I want you to circle these right here. They are in the x squared family. So those would be considered like terms because they all have an x squared at the end of them. Now I want you to take that same red pen and underline 5 and 6. Those are numbers that stand by themselves. Because they are both numbers that stand alone, they're both constants. That means they are in the constant family. Now I've got a final 2 here. If you would circle this with your red pen, 8x and 10x. Guess what family they are in? The X family, okay? So because of that, they are in the X family. They are like terms because they're in the same family. They're raised to the same power. And then simplest form, we're going to talk a lot about that. It means that there's no like terms left. For section number 1, it tells us to identify the terms and the like terms in the expression. Tonight on your homework, you're going to have something that looks exactly like these instructions. One thing I want you to remember is this next saying, and I want you to write it down with your red pen. Every number has a sign, and that sign is directly in front of that number. If you haven't written it down yet, please write it down with your red pen. Everybody else, read me once again what that saying says. Every number has a sign, and that sign is directly in front of that number. It's going to be super important to remember and know that for today's lesson. First things first, I'd like us to circle and underline the things that are in the same family. So take your pencil for me, and I want you to underline the 9x. Does anybody see any more x's up there in my original problem? What is it? X. Okay, now every number has a sign, and that sign's directly in front of that number. What sign do you see in front of the x? Negative. So I want you to underline negative x. Now this right here, there is just one x there at the end. So if you would, take your red pen, and we're going to put in a little understood 1 there. Now I have some other things that are not in the x family. These are in the constant family because they are numbers that stand by themselves. I've got -2. What's the other number that stands by itself?
7.
positive 7. Please circle it with the positive or negative directly in front of it. Now what I'd like you to do is look up at the top and read to me the definition that we have written down in our notes at the very top for what terms are. What are terms, class?
Parts of the expression being added or subtracted together.
Very good. What's the very first term that we see in problem A? The very first thing we underlined. 9x. Everybody underline or write down 9x. The next term we see that's directly next to it is a -2. Everybody write a -2. Jocelyn, what's the next term that we see in problem A? A 7. Everybody write that down. And there's one final term here. Ellie, what's the final term?
1x.
Not 1x. Every number has a sign, and that sign's directly in front of it, -1x. All right, so those are the 4 different parts that we are adding or subtracting together. The next thing it asks us to find is like terms. Like terms are terms that are alike. So let's start with the very first term we have, 9x. Is there anything else in the x family?
Yes.
What else is in the x family?
-1x.
Very good. So we're going to write 9x and -1x. Now you could put that -1x there, or you could just say -x. It means the same thing, okay? Those are not the only things that we see alike. There's something else that's alike there. Did anyone else catch what else is alike in our original problem? Reagan, what is it?
There are both constants.
Very good. And what are they?
-2 and +7.
Very good. Everyone write that down. Those are like terms because, as she just said, they're both constants. They are numbers that stand alone and they don't have any letters attached to them. The next one, coefficient. Everybody go back to your notes at the top of your page. Please read to me, what is a coefficient, class?
The number part of a variable term.
The number part of a variable term. Remember, a variable term is something that has a letter with it. Do we have anything there that has a letter with it?
Yes.
What's the first thing we see that has a letter with it?
9x.
9x. Looking at 9x right there, what's the number part of 9x?
X.
9. 9 is the number, so 9 is our coefficient. Are there any other coefficients in the original problem?
Yes.
Yes, what is it?
1.
Not 1, but
-1.
-1. Okay, if you look back at this one right here, that is the number part of the variable term. The -1 is attached to an x, so that's called our coefficient. The final thing we want to identify, remember identify just means look for and tell me what it is. We're looking for or identifying the constants. Everyone go back to your notes at the top of your page. Read to me the definition of a constant.
A number that stands alone.
A number that stands alone. Do we have any numbers that stand alone?
Yes.
What are they?
-2 and +7.
Very good. So we're going to write that down. -2 and +7 are the constants. All right, on problem B, once again, we're doing the same idea, identifying these terms. Let's underline and circle so that we can separate what the different terms are. The first one, I see something here in the X family. Abby, is there anything else in the X family?
5x.
Not 5X. Every number has a sign, and that sign is directly in front of that number.
Negative.
-5X, excellent. Let's underline that. Abby, is there anyone else in the X family? No. Now I do see some numbers that are standing alone. The 7 and what else?
10.
The 10. Very good. Every time you have these expressions, I want you to underline and circle what the like terms are. All right, so here we go. Now that we've done that, we're going to write down the 4 separate terms from our problem. Michaela, what's the first term that we see? -3x. All right, guys, make sure you're writing this down with your pencils. Michaela, what's the next thing that you see right next door to the -3x?
7.
A 7. Write down the 7. What else? What other terms do you see, Michaela?
10.
A 10. And the final term?
-5x.
Very good. All she did was she identified the different parts that we're adding and subtracting together. Next up, like terms. Like terms are the terms that are in the same family. Autumn, I can see a -3x. Who else is in the -3x family?
-5x.
Very good. Those are like terms because they are both from the x family. Luke, do you see any other like terms there?
No, 7 and 10.
Very good. 7 and 10, those are constants. Those are numbers that stand alone that don't have a letter attached to them. Next up, coefficients. This is one of those tricky words that we don't just have in our regular vocabulary. So let me have you guys flip to the front of your notes where we just wrote what the definition of a coefficient is. Class, what is a coefficient?
The number part of a variable term.
The number part of a variable term. So when looking for a variable term, you have to go back to the original problem and find something that has a variable in it. All right, I just highlighted them in blue, but I don't want the whole variable term. I only want the number that's attached to the variable term. Jonathan, what's the first number that's attached to a variable term? -3, that's correct. So that's a coefficient. Jonathan, do you see any more coefficients? Which one? No, +7 is not attached to a variable, so that's not a variable term. Only look for the variable terms. -5, very good. So there were only 2 coefficients because those were attached to a variable or they were attached to the x. Let's look at the last thing we want to identify, the constant. Does anybody remember what a constant is? If you don't remember, you can go and flip back to the front page of our notes from today. Jacoby, what's a constant?
A number that stands alone.
Very good. Do you see any numbers that stand alone?
Yes, ma'am.
Which ones?
7 and 10.
7 and 10 are correct. All right, so we have now identified those 4 different things in our problem. Now, for this next one, there's something new that I do want to teach to you. What one variable do we see up there, class? A y, okay? Now, there's something unusual about the y. Not all y's are by themselves. What do you see on that first one? It says y to the second power, and we're going to call that y squared. Let me explain to you. You don't need to write this down, but I do want to explain something to you. These two are not in the same family, all right? One is the y family, and one is the y squared family. 2 separate families. They look alike. They both have y's in them, but those are 2 separate families, okay? So let's underline and circle the things in the same family. Underline the y squared. That one right there, if you want to, you can take your red pen and put a 1 because there's only one y squared right there. Do you see anybody else in the y squared family? Michaela, who else?
3y to the second power.
Okay, not just 3y. Every number has a sign, and that sign is directly in front of the number. Very good. -3y squared. That is the only thing that's in the y squared family. But there's another family up there. Who's the other family, class? The y family, just the plain old y family. Everyone circle +5y. Who else is in the y family, class? Just the plain old y. That one at the end, if you want, there's an understood 1 in front of it. So you can slip that in there if you want, and I'm going to circle +1y. Now I want you guys to write down the 4 terms that you see there. Who would be willing to tell me the 4 terms that you wrote down? Jacoby, what are your 4 terms?
Y squared,
Y squared?
5 y, and then -3y squared, and then just y.
Okay. He did not put the ones in there, and that's totally fine. You do not have to. Who would like to help me with the like terms? There's some people up there that are like terms, or they are in the same family. Luke, who do you see there?
The y to the y squared.
Okay, y squared, and who's in his family?
Then -3y to the second power.
Very good. Do you see anyone else in the same family?
The 5y
5y
and just the regular y.
and the regular y. Okay, those are in the y family. Very good. Next up, the coefficients. Does someone remember what a coefficient is? Jonathan, what's the definition of a coefficient? Very good. The number part of the variable term. Okay, so you've got to look for the letters and see if there are any numbers attached to those letters. Jonathan, what numbers do you see attached to the letters, or what coefficients do you see? I see a +5. Very good. Any others? A -3. Any others? There's one more, and this is why I say to slip the ones in there so that you can see there is a 1 there, okay? So the last coefficient we can see that is attached, even if we don't visibly see it, is a 1. Okay, very good. Let's go to the next one, constants. Remind me, class, what does a constant mean?
The number.
Okay, everyone say it. A number that stands alone.
Number that stands alone.
Very good. Autumn, what are my constants?
5y.
No, that 5 is attached to the y. Jocelyn?
Y.
No? I want a number that stands alone. Michaela?
None.
There are not any. That was a trick question. The answer is none. If I had had something up here that said like plus 13, that would have been my constant. But because I didn't have any numbers that stand alone, I'm simply going to slip in the word none. All right, this next set of instructions is different than the last one. This says to simplify the expression. A lot of times people have a hard time when they see that it says to simplify, because that does not mean evaluate, it does not mean to solve. It means to make it as simple as you can, all right? So here's how you do that. In red, if you haven't written it down yet, please pull out your red pen and I want you to write this down. Combine the like terms, and what that means is add the coefficients and the constants, all right? The coefficients or the constants. So the first thing we're going to do every single time, tonight on your homework, you're going to write down the original problem, and then I want you to underline and circle the like terms. So the first thing I see here is 6n. Who else is a like term with the 6n? Class?
Negative 10.
Everybody underline the negative 10n. Is there anybody else that is like terms with the n family? No. The 4 is what we call a what? A constant. Very good. That's a number that stands alone. So I'm not going to underline that because that's not a like term. That's a different term. Now what I have to do is combine the like terms. Let's combine the n family. I have 6n and negative 10n. Class, is that the same sign or a different sign? Different sign. Same sign. Add and keep. Different sign. Subtract and take. So what would 6n minus 10n be? Negative 4n. We subtracted. 10 minus 6 is 4, and we took the sign of the larger number, which was a negative. And now what we're going to do is pull down plus 4. I'm going to show you what a lot of people think the answer would be at this point. They think, oh, negative 4 and positive 4. The answer is 0. But here's the sad thing. Those are not in the same family, which means you are not allowed to try to combine them. I have the n family and I have the constant family. That is as simple as I can make this, and that is my final answer. So many times when you see something in the instructions that say simplify the expression, that just means make it as simplified as you can, but then you're going to still leave the answer looking just like that. Okay? Let's go to the next one, problem B. Ellie, we're going to underline and circle the like terms. The first one I see is negative 8y. Is there anyone else in the y family? Okay, underline 6y. Anyone else? Regular y. And I'm going to go ahead and put a 1 there so that I understand that is the coefficient in front of it. All right, Ellie, no one else is in the y family, but who else do you see there that is like terms?
42.
Good job, everybody. Circle positive 4 and circle positive 2. What we're going to do right now is just focus on the y family. This is negative and this is positive. So let's just add. We're going to do some mental math. Class, if I was to add 6y plus 1y, what would that be?
7y.
7y. Okay, very good. So technically, this right here, you don't have to write this down, but this is 7y. And I have negative 8y. Same sign or different sign? Different sign. Subtract and take the sign of the larger number. What is negative 8y plus 7y?
Negative 1y.
Negative 1y is correct. We're going to write that down, negative 1y. Now I have some constants, some numbers that stand alone. 4 and 2. Combine those two together. What's positive 4 plus positive 2? Positive 6. So you have to put positive 6. Can I combine those anymore? No, they're not in the same family. So no matter how much I want to make them in the same family, they will never be in the same family, okay? I have Autumn and Jocelyn in here. They're nice girls. They're friends, okay? But no matter what, they will never be in the same family. These numbers or expressions, these different terms cannot be in the same family. Let's go to the next one. To Kobe. I see the X family. Do you see anyone else in the X family?
I see negative 4x and 8x and 4x.
Oh, look at that. They are all in the X family. Now, do you guys remember a number and its opposite? Let's talk about that. If I have 5 and negative 5, what's the answer? 0. If I have 10 and negative 10, what's the answer? 0. If I have 30 and negative 30, what's the answer?
0.
So if I have negative 4x and positive 4x, what's the answer? 0. So you could take your pencil and cross that out. Jace, what's left? 8x. And that is our answer. That's as simplified as we can get it. That's why we like those shortcuts, all right? That was the inverse property. The opposites tell us we can cancel them out. Let's go to the next one. All of these are in the W family. This last one right here, what number could I stick in front of the W?
1.
A 1. Let's put the 1 right there. Now what I'd like us to do is combine the positives first. Does anyone know what 5.2W plus 1W would be? All right, I heard a couple different things. Here's what I want you to see. Someone said 5.3. If I did that, think the decimal point is technically right there. Did I line up the decimal points? No, but you have to line up the decimal points. So instead, if you were going to do that, you could put a 0 as a placeholder. What would that be, class? 6.2. Very good. Okay, so we're going to write that down here. This is 6.2W. We still need to bring the rest of that down. So we've got negative 8.5W plus 6.2W. Class, is that the same sign or a different sign? Different signs, subtract and take. If you don't know how to do it in your head, once again, come off to the side and do it off to the side. Who could tell me what the answer is once you've found it? Ellie, what'd you get? 2.3. Take the sign of the larger number. Negative 2.3W. And that is as simplified as we can get it. Any questions on that one? Looking at problem E. Class, what family is that in? The B family. Okay, so we know our answer is going to be something B. Right now I want to focus on the coefficient. Remind me again, what's a coefficient? The number part of a variable term. So I'm just going to focus on the number part. 3/8 minus 3/4. When adding and subtracting fractions, what do I have to have? Common denominator. What's my common denominator? 8. So I'm going to multiply this side by 2 to get the common denominator. Let's drop this down. I've got 3/8 minus, what will that be? 6/8. Very good. Looking at that now, class, same sign or different sign? This is a positive, and the other one is a negative. Same sign or different sign? Same sign, add and keep, different sign. Subtract and take the sign of the larger number. What's the answer? Negative 3/8. And what family did we say we are in?
B.
B. Box it in. All right, let's do problem F. Who could help me with circling and underlining the like terms? Reagan, what will I do?
You'll underline negative 10y.
Very good.
And underline negative 5y.
Excellent.
And circle positive 15.
Very good. Let's go ahead and combine the like terms. Reagan, what's negative 10y plus negative 5y?
Negative 5y.
Same sign, add and keep. Add the numbers, keep the sign.
Negative 15y.
Negative 15y is correct. And then bring down your plus 15x. Reagan, can I combine those two? Should my answer be 0? No, why not? They are not like terms, or they're not in the same family. Because of that, we have to keep the answer just like that. For this last one, I've got a 7. Who else is like the 7? -5. Then I've got the P family. Who else is like the P family? 3/4 P, and who else? Regular old P. I'm going to put a 1 in front of it. And then that X. Is there anybody like the X?
No.
No, unfortunately not. So I'm actually just going to box it so I can see that's different. Now I'm going to write down all of my terms. Remember, the terms are just the different parts that we're adding together. Now we've got like terms. Who could tell me what one of the like terms are? Jocelyn.
3/4 P and
3/4 P and P. Very good. That's the P family. Who else can tell me like terms? Jonathan.
The 7
The 7 and -5. What about the 2X? Does the 2X have anyone else like him? No, he's kind of like me. I sadly don't have any family here in Jacksonville.
Me neither.
I'm all alone, all right? Just like that poor 2X. Now, the next one. On your homework tonight, you're going to see some things where it tells you to identify. That means look for. And the next ones will say simplify. Simplify means to combine your like terms as much as you can. So everybody underline and circle. And here's a fact that I'd like to teach you. Whenever you underline and circle, when you start to combine the like terms, you have to put your variable term first, and then your constants will go at the end. So can anyone tell me what you got for answer number 2? Ellie, what'd you get?
7P and 4P and then 6.
Guys, we're going to combine 7P and 4P. What is 7 plus 4P? 11 what? P. Plus, what else? 8. Can those be combined together? No, they are not in the same family, so that is your final answer. All right, tonight you do have homework. It is 3.1, and you will find this on Big Ideas.